In this lesson, we're going to go through some more simplification of algebraic expressions. Now, I'll provide a link in the top right-hand corner for the previous video, but I just want to extend that a little bit. Now, looking at this expression here, we know that we're looking for like terms. I know I've got a 4x term, and I have a 2x term. So 4x, subtract that 2x, is 2x. I know I have a y term, this plus 5y, and another y term here, plus 3y, and obviously 5y plus the 3y is plus 8y. Now looking at this second question, we have an xy term and a yx term. And the question is, well, is xy the same as yx? And the simple answer is, well, yes it is. And I'll show you why. If I have an x value of 2, and a y value, let's say, of 3. I know that xy means x multiplied by y. In this case, it's 2 multiplied by 3, which is 6. Now yx is also y multiplied by x, which would be 3 multiplied by 2, which is also 6. So xy and yx are the same. We can write the variables in any order. So 6xy plus 3yx is actually 9xy. Now if you notice, I wrote xy rather than yx. It is common practice to put the variables in alphabetical order. On to the next question, and we have some terms involving a's and b's. So I need to have the same order of a and the same order of b, and by that I mean the powers. So if I look at this term here, this a squared b term, I'm looking for any other terms that have an a squared b. And we have this one over here, this negative 2a squared b. So 4a squared b minus 2a squared b is 2a squared b. Now what I have left is this 2ab squared plus another ab squared. So those terms are the same order. That gives me plus 3ab squared. Okay, on to the next question. Similar sort of thing. I have x's and y's, but different powers again. So I'm looking for something with the same order. I have this term here, which is xy squared. And I notice over here, I've got another plus 2xy squared. That will give me 5xy squared. Now looking at the other terms, well, I've got this plus 2x and I've got 3y. There are no other like terms. And then just finish off with the 4x squared y squared. In this question, we've got x's and y's. And if you notice, the second term here, we've got 3yx. In the first term, we've got 2xy. So again, those variables have just been placed in a different order. Now what I could do is to rewrite this as 2xy plus 3xy minus the 2xy minus, and this one here would be xy. Now I don't usually do that. You can do it if you wish. It is sometimes useful on questions where there are multiple different terms. But in this question here, I probably wouldn't do that. So I notice that this 2xy will cancel with this one, and that just leaves me with 3xy minus xy, which is 2xy. On to the next question, and we notice in this question that in each of the three terms, I have an a squared, I also have a b, and I also have a c. In terms 2 and 3, that order is different, but we know that doesn't matter as long as we have the same order. So I've got 4 minus a 2 minus a 3. That will give me a negative 1. Now we know we don't write the 1, so it's just going to be negative a squared bc. Next question, I've got 5 terms here, but I notice over here I have a constant. No other like terms of that one. But the other 4 terms involve x's and y's. Again, written in different orders. We know that doesn't matter. So I've got the 2 and the 4, that's 6. The single xy, that's 7. 7 minus the 3 is 4. So it's 4xy plus that 2, that constant. On to the next question, and we've got h terms all along here. Now they are different order terms. I've got a h cubed of 2h squared, and then the 3h and the plus h on the end. So the only two like terms are actually these ones here. So the final answer on this one would be h cubed plus 2h squared plus 4h. So the 3h and the h make that 4h. Next question, and we have 4 terms. Now the only like terms here are this one here, the GH, and the HG term. Again, in different order. We know that doesn't matter. So that's 3GH. Then we have the G term, and we have the H term. Now I know a lot of students would actually look at this and say, well, can we write that as GH? Well, no, we can't. We know that when we've got two variables next to each other, it actually means multiply. So that means G multiplied by H, and clearly we are adding. So we can't simplify like that. So those two single terms stay as they are.